All right, this is actually our Chapter 8 quick notes, our gold notes, okay? And it looks very different than sometimes we normally see. So if you want to write at the top of your paper, like Chapter 8 quick notes or something like that, just so you can remember when you go to study for your exam that this is the Chapter 8 one. So I decided to do this graphic organizer because so much of what we learned in Chapter 8 blends together. And what we learned in one section, we needed for the next section. And as far as like organizing and going through the different quadrilaterals, sometimes they share the same properties and sometimes they are different. Okay, so this is kind of a way to organize and see how they are the same and how they are different. So our chapter is about quadrilaterals. Okay, so we kind of started out in 8.1 with all polygons, but we learned some general rules of all quadrilaterals. Okay, so one of these general rules that works for everything is they are four sides. Okay, that's a given that has to happen if it's a quadrilateral. Okay, so with the four sides, we know there are exactly four angles. Okay, and that's true for every quadrilateral. Now, what we are talking about and what you can even see in this picture with all these quadrilaterals, these are always convex, okay? So this is, I probably should put this little note, this is for everything that's convex, okay? If things cave in, none of these rules apply, okay? There's still four sides and four angles, but the rest that I give you are gonna be different. Okay, so one of the other things we learned in 8.1 was if we add the interior angles inside of a quadrilateral, they will all add up to 360 degrees. Remember, triangles added up to 180, but quadrilaterals now add up to 360. And then we also have our exterior angles, that if I add all those exterior angles, there's four of them, they will always add up to 360. Quick reminder, all exterior angles on all shapes add up to 360, but in a quadrilateral, we also get 360 on the inside. Okay, so that's true for every quadrilateral in this chapter, all these properties. But then we started dividing into different sections and different other things that we did. So in 8.2 and 8.3, okay, so this was 8.2 and 8.3, we talked about parallelograms. And there are 5 distinct properties for every set of parallelograms, okay, for every parallelogram. The first thing is, by definition, the opposite sides are parallel. True for all parallelograms, okay? Then we had properties like opposite sides are congruent, okay? So they have congruent on the opposite sides. We know that the opposite angles are congruent. We know consecutive angles, because of our parallel lines, our consecutive angles are supplementary, okay? They add up to 180. So our consecutive angles are supplementary, okay? And our fifth and final rule for all parallelograms is the diagonals bisect each other, okay? Remember, that means that they, on one diagonal, the pieces of it are congruent, and so they cut through a midpoint of each one. So that's the rule for all parallelograms, okay? Now, the way this chart works is that when you see those rules for quadrilateral above the parallelogram, all of those are true for a parallelogram as well, but now we got more specific with our parallelogram rules. Okay, so now when we go to rectangles and rhombuses, they have all the properties above it from the parallelogram, okay? But now they have some of their own properties, okay? What's special about a rectangle that's different from all parallelograms? They have 4 right angles. Okay, so all rectangles will have 4 right angles. And we also know that all the diagonals in a rectangle are congruent. Okay, both of them, right? All of them. Diagonals are congruent, and that's true for every rectangle. Now, what's true for every rhombus? Well, there's 4 equal sides. We also know that the diagonals in a rhombus are perpendicular. That's a huge thing. We can put that right angle in there. We also know that the diagonals bisect the angles. And that's really important because when the diagonal cuts through, both sides of that angle will now be congruent. Not true for every rectangle, not true for every parallelogram, but it's true for every rhombus, okay? And then we get down here to the square. Now notice it's below the other ones. That means that everything about a rhombus above it, everything about a rectangle above it, everything about a parallelogram above it, everything about a quadrilateral above it, all of those are rules for this square as well. So instead of rewriting them, I just put it on the lower to say everything above it is true, okay? So is there anything new that's special for these squares? By the way, this rectangle, this was all from 8.4. Rhombus was 8.4, square was 8.4, if you want to look back in your notes for any of these, okay? So with all these properties above it, we really know everything we need to know about our square. The only other thing I can think of to write is we can put it's regular, because all sides are equal and all angles are equal, but really that's covered above it, but everyth's there, okay? In fact, I'm gonna write this little disclosure at the bottom of my chart. The properties follow the arrows. Okay, properties follow the arrows. So if this makes sense, the lower shape possesses, the lower shapes possess all properties of the shapes above. Okay, so again, that square has all the properties of those things above. So I don't want to forget that, so I'm going to write that. So if I look back at it in a month or two, I remember, oh yeah, everything above that is true for the square. It's not that the square doesn't have many properties. The square has the most properties, but we already listed them all, so I'm not going to relist them. Okay, so notice that was all on one column because those were all similar. We spent all those sections going over those. Then we made it to 8.5, okay? And in 8.5, we said, okay, we have these new shapes, trapezoids and kites, that don't follow all the properties from those parallelograms. In fact, they don't have those, very few properties, right? So 8.5 tells us we have a trapezoid. Really, all we can categorize it right now is a quadrilateral. Has the four sides, four angles, 360 inside, 360 outside. So what's true now about these trapezoids that's not true about those parallelograms beside it? Well, there's only, okay, one pair of opposite sides parallel. Okay, that's so important. Only one pair of opposite sides are parallel, okay? That's really the definition and stuff. So there's a few other things we talked about I want to put here. Your pair of non-base angles, okay? So we're talking these two right here that are not touching the same base. The pair of non-base angles are going to be supplementary. They equal 180, okay? So that's really important to remember about all those trapezoids, okay? And the other thing I want to make sure we put on here, because this is true for the trapezoids, is the mid-segment, okay, equals 1/2 of base 1 plus base 2. Okay, that's so important we have that. The mid-segment is equal to 1/2 of base 1 and base 2. And I should put is parallel to the bases, right, if we need to know that. So that's all about that mid-segment. So that's true for every trapezoid. Then let's go beneath that, because there's new properties here if I say I have an isosceles trapezoid. Okay, so if I get into those isosceles trapezoids, I have this new property that I have legs are congruent. That's what kind of makes it isosceles, right? The legs are congruent. Then I have two pairs of congruent base angles, okay? I get angles that are congruent. So this angle is congruent to this one, and this one down here is congruent to this one down here, okay? Two pairs of congruent base angles. And we had one more property where the diagonals are congruent. Okay, so everything we listed about the regular trapezoids above it, one pair of opposite sides parallel, that's still true. Non-base angles add up to 180, that's still true. Mid-segments 1/2 base 1 plus base 2, that's still true. But we add these specifics now to an isosceles is that the legs are congruent, two pairs of congruent base angles, and diagonals are congruent. Okay, then we come up here to kite. So what's special about a kite that is different than the other shapes, okay? Right now, the kite does not follow anything from the parallelogram column, nothing from the trapezoid column. It's got its own column, but it's still a quadrilateral, so 4 sides, 4 angles, and inside angles are 360, exterior angles are 360. But what's special about a kite? Well, there's 2 pairs of consecutive, congruent sides, consecutive though, instead of. And I'm going to add right to that beneath it to make sure we know. Opposite sides not congruent. Okay, that's so important because remember, some people are like, oh, I think a rhombus is a kite. No way, it's not allowed to be, okay, because of our rules. What else do we know about a kite? The diagonals are perpendicular. Okay, so that's super important because it allows us to make those right triangles and find some things out. We have exactly 1 pair of opposite angles congruent. Okay. And one more thing I need to add on here. And this is something we kind of discover when we look at these later. These angles that are congruent, they have a diagonal. This one has it. This diagonal that goes through the opposite angles is bisected. So one diagonal is bisected. Okay, so that's kind of like an add-on rule. It didn't really say that in our notes, but we want to add that because it's important to know one of them will be. The second one definitely is not bisected, but one of the diagonals is bisected. Okay, so hopefully this kind of pulls all of our properties together from all of our shapes, okay? This is important as we go into, like, when you went into those 8.6 notes to say, I want to decide between these quadrilaterals what we have. This is the sheet that really goes through those properties, okay? All right, let's flip it over though, and let's get those properties, some other quick rules that we had for extra ones that I want to make sure we have for Chapter 8, since these are our Chapter 8 gold notes. Sum of the interior angles of a polygon. So this is back from 8.1. So when we want to find how much all the angles inside of a polygon are, we do n minus 2 times 180. Remember, n is the number of sides, right? If you need to write that, n is the number of sides, okay? And if I want to find the sum of the exterior angles, no matter how many sides, it's always 360. There's no other thing to figure out, okay? We also did a few that if it was a regular polygon, what's one of the interior angles? So we can find the sum by doing n minus 2 times 180, but if I want just one of them, I divide by n. And if I want just one exterior angle of a regular polygon, I just do 360 divided by n. Okay? So there's our gold notes. That's what we want to use as a quick reminder of everything we learned in Chapter 8. Make sure you're filled out and use them as you go through review guides, as you go through and study for exams and such. Let me know if you have any questions.